right, welcome and thank you all for being here at the first college lecture for engineering here in the fall 2022, and we are excited for what we've got in store for you. My name is Michael Jensen, and I am Dean of the College of Engineering, and we're delighted to have all of you students and other friends who are here. We're also grateful to have our honored alumnus who will be speaking to us, Michelle Burnham, and I'll introduce her in just a moment. Before we get going, we just want to point out to you, we typically don't make a lot of announcements here, and you've seen the reel going, but the Engineering International Fair, the date was changed, and we want to make sure you're aware of it. It will be immediately following this lecture from 12 to 2 over in the event space in the engineering building. And so if you have interest in international opportunities, study abroads, internships, please go over to that international fair and you can learn that. We will open here today our meeting with an opening prayer by Bryce Marshall, who was a freshman studying mechanical engineering here in the college.
Our Father in heaven, we're grateful for this opportunity we have to be here together today. We thank Thee that for this university, for the freedom of religion we have, and for the blessings of faith that we receive as students as we seek an education. We thank Thee for the faculty and staff that have made this meeting possible. We ask to please bless Michelle Burnham and the other presenters, that they'll be able to be blessed and share with us the things that will be important to us as students. Please bless us to focus on what's most important in life, and that we'll focus on learning and focus on our families and our faith. We again thank Thee for our families and for the blessings we have to be students here at this university, and we say these things in the name of Jesus Christ. Amen.
Thank you, Bryce. Before I introduce Michelle, let me just say that we invite you to be back here in this room at the same time on November 17th for our next college lecture. The speaker will be King Hussein, who is a graduate and an alumnus of our civil engineering program, and is a founder of Span Construction, who helped build the engineering building and also who builds all of the Costco's worldwide. So that should be very interesting. And following our lecture today, we will have a benediction that will be given by Ivy Stout, a senior in civil engineering. Now let me introduce our honored alumnus today. Just so you students are aware, every year, every college in the university chooses an alumnus who represents the values of BYU, who goes out and distinguishes themselves. And we are very honored to have Michelle Burnham as our honored alumnus for 2022. Now, Michelle completed her electrical engineering degree back in 2006. She was actually kind of an anomaly because she did capstone with the mechanical engineering program, which is now electrical, computer, and mechanical, and manufacturing all do it together, but at that time it was a bit unique. Upon her graduation, she received some on-the-job training in the petroleum engineering industry at ExxonMobil, and she obtained her professional engineering license from the state of Texas in 2012. Additionally, she received an MBA, which is always a great path for engineering graduates, from the University of Texas at Austin in 2011. She has worked on many U.S. onshore oil and gas fields at both ExxonMobil and Anadarko Petroleum, and she now works in engineering consulting with Netherland, Sewell Associates, Inc., where she currently acts as a vice president. She provides reservoir engineering services to U.S. and international oil and gas companies, banks, and governments, and has worked on oil and gas projects in South and Central America, Africa, and Australia. In 2012, she started the Mechanical Engineering Capstone Assistance Endowed Fund to support humanitarian-centered BYU capstone projects. She remains actively involved in these projects and served as the industry liaison for the project in the 2019 and 2020 school year. So now I ask you to join me in welcoming our speaker and an honored alumnus, Michelle Burnham.
Thank you, Dean Jensen. I'm really excited and humbled to be here today with you. I'm only about a third of the way through what I anticipate will be a 45 to 50-year career. So I certainly don't have all the answers, but I have some things that I'm very passionate about and excited to share with you today. So the title of my presentation is a thinly veiled nod to my favorite sci-fi show growing up, Star Trek. And I think the word bold is really appropriate when we talk about how we can approach our careers. So I'm going to share some personal stories about what I think it means to be bold and how to accept new opportunities. And then the next thing, of course, I'm very excited about is power, in this case, the quantifiable kind, which is the industry I work in, the energy industry. So I want to share a little bit of where the world is at the moment in terms of energy consumption. You are all consumers of energy. Some of you probably used hot water this morning when you got ready to come here. You might have used some gasoline in either the car or a bus. We're sitting in a room that's using electricity. We're all consumers of energy. And I think as engineers, it's important to understand where it comes from so you understand what you're using, and then what the opportunities are from a career perspective. So I'm going to start with the energy portion of my presentation with global trends. So this is information that the US government publishes in their Energy Information Agency, which was set up after the 1973 oil embargo, when it became really important to understand what kind of availability that we had as for energy. If you notice, back in 2000, it was about 400 quadrillion British thermal units, very big unit. But the thing to note in the chart is over the last 20 years, which is most of your lifetimes, it has increased 50%. So now the world consumes over 600 quadrillion BTUs. If you look at the wedges, I have them colored by source. So you have oil, natural gas, coal, nuclear, and renewables. With the exception of nuclear, all of those wedges have increased over the last 20 years. So consumption is way, way up, and it's projected to be so for the future. If we look particularly at the US, which would be kind of my next thought, I wonder what the US is like. This is, again, a chart from the EIA they published back in March of this year. We have the history side and then their projections forward. This is their reference case. We've been pretty flat over the last 20 years. Back in 2000, we were 25% of the world's consumption, and now we're about 1/6. If you again look at the colors, the gray one represents coal. So coal has shrinked significantly over the last 20 years, but all the other areas are projected to increase. So you can see renewables, there's an expectation that there are going to be some breakthroughs and we can increase our renewable consumption. We're currently at 8%. But in the US today, 68% of energy is consumed in natural gas and oil. There's a lot of discussion about electrification, and I think I was in a car that was partially electric today. Do you know where the electricity comes from when you go to charge your laptop or your phone? Let's take a look. So currently in the US, and I'll admit I was surprised by this number when I pulled the numbers out, 23% of our electricity is produced from coal, and 37% is natural gas. And then it's split pretty evenly, about 20% between renewables and nuclear. So that's today's current position. I want you to know when you look at the chart that I had just showed previously with the history, when I started my career in 2006, they were projecting coal to be a significant contributor in the future, and instead it has decreased. So these projections are just that, projections. And anything can change in the course of your career, and I have seen a lot of things change just in the last 15 years that I have been in the industry. From a career options point of view, I will admit I was surprised to realize how large it was when I actually entered the workforce, even though I was a consumer just like you sitting in these seats back when I was in school. You have the fuel sources we just described, the people who are working in the natural resource space on extraction, and then there's also a secondary, or what we would call downstream options like pipelines or power generation and transmission lines. This need for energy is increasing, and there's a lot of engineering opportunities and problems to be solved there. And then on the chemicals and refining side, how do we get it into products that you can use as gasoline in your car, as well as some of you may be wearing clothing today that consists of polymers that were part of these products, or you're going to go buy your lunch in the Cougar Eat that might have some plastic wrapping on it. Packaging, we are surrounded by products that come from the energy space. So specifically, I work in oil and gas, and again, as engineers and consumers, I think you should know where it comes from. So you've probably heard that there's wells that are drilled and it's in the ground, but where exactly is it in the ground? This is a picture of a core sample. So this is rock that was taken from 1.5 miles to 2 miles down in the ground. You can see the cylinders were taken up at the surface and it kind of gets broken into pieces. If we take a cross section, slice a very thin piece across one of those cylinders and put it under a microscope, we might see something like this. And those are grains. Those individual brown grains are stacked together and cemented together, and that blue represents the open space. And in that open space is where oil, gas, and water could be located. And if we're looking for oil and natural gas, that's the one we're looking for. So it's held in the pore spaces of rocks, which to me is just amazing that you can hold up a piece of rock and that's where our energy has been coming from, is the little bit of fluid that with a pressure drop, it will come out. One of my kind of jokes, since I love Star Trek, is instead of being an outer space explorer, I'm a pore space explorer. So, the sort of double meaning of the words there. Not all rocks are going to be as good as this. 23% porosity, which is this one, that means 23% of that image is open space. There's a lot of rocks in the US that are not as good as that, and were not considered commercial. And one of the things I want to share about how this industry has changed, and that in your career, things can change significantly in any area. There has been a real revolution in how oil and gas has been able to be commercially produced in the US, and I have a little video that's going to describe that and also kind of illustrate a little more about where this comes from.
Oil and gas. Its formal name is hydraulic fracturing, and around 2007 it took off, making the US the top oil and natural gas producer in the world. But fracking isn't actually new. It was invented in the 1940s, but kind of overlooked for decades. So, why did fracking all of a sudden become this huge deal? The answer is a three-part story of geology, economics, and technology. And pastries. Let's start with number one, geology. Oil and gas is found in sedimentary rocks, which are made up of a bunch of ingredients: sand, mud, and prehistoric life. They're mixed together, deposited, and baked underground for millions of years. Some of these rocks are porous, meaning they have big holes that can hold fluid, kinda like jelly donuts, with pockets of delicious and energy-rich oil and gas in the middle. Getting oil and gas out of these jelly donut rocks is simple. Drill a well, and the pressure from all the rocks above will push it to the surface. Other rocks end up more like layer cakes. And just like cakes, some of those rock layers are also porous. But instead of big pockets, they have lots of teeny tiny cavities that can hold fluid. Fluid like chocolate sauce or energy-dense oil and gas. Often, these layers aren't permeable, meaning all these teeny tiny pockets of oil and gas are locked up. They can't flow anywhere. To get the oil and gas out, we have to create cracks and channels by pumping water, sand, and chemicals down inside, fracturing the cake, the rock. That's fracking. Now, fracking a layer cake is trickier and spendier than sucking the filling out of a jelly donut, which brings us to the second part of our fracking story, economics. Turns out, the US is filled with lots and lots of jelly donut rocks and layer cake rocks. But after 150 years of drilling, those cheaper, easier jelly donut deposits were running out. By the early 2000s, energy companies and policymakers in the US were getting seriously freaked out. Where will all the oil and gas come from? From the unstable Middle East, or from countries in crisis like Venezuela? The options weren't good. As the price of oil and gas went up and up, the US also entered a recession, leaving people hungry for economic opportunities. Those expensive, tricky layer cake rocks began to look a bit more tempting, whipping up investment in element number 3 in our fracking story, technology. We got better at drilling way deep into the earth. Plus, we figured out how to drill horizontally, creating many more cracks and freeing up more oil and gas. Combining horizontal drilling with fracking, now we could finally extract those tasty little pockets of oil and gas efficiently. By the end of the decade, we had all the necessary ingredients, the geology, the economic conditions, and the technology for a fracking boom. A boom that's made the US the #1 oil and gas producer in the world, but one that has also brought lots of controversy. What does fracking do to the air, to the water, to the climate?
All right, so that video was from a Corporation for Public Broadcasting that has different topics on energy. And there's lots and lots of things we could talk about that. And I want to describe for you how impactful that change was. So the part for engineering related to that is the technology. So the economics and geology are less in our control, but there's a lot of technology advancements that allowed for that. So this is a picture of the oil production by country in 2006. So this is the year that I started my career. The US is in red, and we were in third place at the time, if it's a race. And there's two colors of green here. The dark green represents countries that are not part of OPEC, which includes the US, and the light green is OPEC. So you may have heard of OPEC in the news recently saying last week they agreed they are going to reduce their production by 2 million barrels a day. That is half the distance between the major grid lines on this chart, to give you a sense of scale. So back when I started, when everything that was being produced was mostly through those jelly donut type rocks, and we were looking where else in the world were we going to find them, the US was 8% of production. And then OPEC, which are oil producing and exporting countries, is a cartel that gets together and decides what their production level is going to be explicitly to influence prices. So we use the term collusion to describe that in the US, and we are not a participant of that. But you can see they're definitely a majority, and that's why we hear about them in the news all the time. In the video it described with new technology, we were able to access more oil and gas than we had before, and the US became the #1 oil and gas producer. So where do you think we might be in the chart? If we were sitting in third place, we were at 6.8 million barrels a day. We need to beat out Saudi Arabia, who was at 10.8. If we increased 60% even, which is a huge number, we'd be closer to the 12 million barrel a day line on the chart. So I have the number for last year, which is post-pandemic, so our levels are actually less than they were pre-pandemic. Let's see where we are. Did we edge out Saudi Arabia and wind up around the 12 million mark? Here's last year's number. We blew it out entirely, okay? That's how significant of a change technology is to our ability to have control. And if you look at the pie chart, we went from 8% to 18%. And the dark green part between the 2 years didn't really change. So the other countries haven't changed much in terms of their contribution. It's really the US that has been a real thorn in the side of OPEC. We've been eating into what they feel is like their share and their ability to control. And so that has kind of been a huge dynamic shift during my career. So do you know where in the US oil and gas wells are? Here's a map showing all of them, again from the Energy Information Agency. The oil is in brown and the gas is in blue. Did you know there's oil and gas fields in Michigan or Pennsylvania, New York even? I think we expect to see it in Texas and Louisiana and then the Gulf of Mexico. But how about offshore California, Montana? And I didn't show Alaska on here. There's lots and lots of deposits. The US has been really blessed with a significant amount of natural resources that engineers are finding different ways that we can extract and use for our benefit. So as far as petroleum engineering, which is the area that I went into right after I graduated from the Y, I want to give you a real quick view of what type of engineering is involved in it, as well as in the process you will learn how oil and gas is produced, which I think as engineers who consume energy, it would be important to know. So there's 5 types of engineering I'm going to describe briefly that are involved. The first one is environmental. Environmental engineering is a huge area that overarches everything else because we are working with natural resources in nature. This is a picture of the Trans-Alaska Pipeline, and I'm going to talk a little bit more about that later. The elevated portions of it, for example, have to be at least 10 feet, and that's how it was designed so that wildlife could freely move underneath it. In the western United States, the sage grouse is a protected species, and there's surveys conducted about where they are. There's times of the year that you don't operate. There's environmental engineers that are out doing surveys looking for raptor nests. I have a fellow student that graduated around my time frame who was sent on whale surveys out in offshore of Russia looking for whale pods to understand their migration patterns to make sure that the operations weren't going to impact the whales. So environmental engineering is a huge, huge area, making sure waterways are kept clear. My very first assignment was in a kind of depleted jelly donut type field in Louisiana, and I was always looking for alligators when I was on location. And I have to tell you, everybody I've ever worked with in these areas, they live and work there, and they care really, really deeply about protecting the environment in which they work and the wildlife that's there. So if you're interested in environmental engineering, huge amount of opportunities here. So then we have reservoir engineering. This is the area that I've spent my career in, and I think it works well coming from EE because I'm not used to seeing what electrons do, like at their source, and so I'm a pore space explorer, right, or a rock detective, and the fact that I can't get 2 miles down in the ground and see what's going on doesn't bother me. So instead, I'm using additional outside information to sort of infer what's happening down in the earth, and I love studying the earth. This is a picture of seismic, where you take sound waves that you send down in the ground, and you have listening devices, and we're listening to a time delay on different frequencies coming back, because there's a portion that's reflected and passed through at each interface. And then with supercomputing, we can create an image. This is a slice of the earth with like a well drawn on it to kind of see what the layers look like. We can drill a well and take measurements in that well bore to try to see what the rock is like around there. This would be like taking a measurement in your apartment, in one place in your apartment, and maybe even a video of it, and then trying to extrapolate what your whole neighborhood looks like, right? Because these well bores are not very big, and that's all the information that you're going to get. And so we put that together in simulation models, try to determine what flow rates we're going to get and what facilities we need, how many wells, and is it commercial. So this is the space that my career has been in. Then we have facilities engineering. I want to share with you what has been an engineering marvel that was in this space. So if we go back to Alaska, there's huge oil and gas fields up in northern Alaska. And that with the oil embargo in 1973, again, it became really important in the US to have a little more control. So there was a team of engineers. They were going to install a pipeline from the whole length of Alaska, from the top to bottom, to be able to export it. The construction of this project was between 1974 and 1977, so it's been a while. There's some huge challenges in this area, right? It's 800 miles long, very, very harsh conditions. It was designed for minus 80 degrees Celsius up to positive 95 degrees, so huge temperature swing. And if you're dealing with oil and gas, as temperature and pressure changes, the volume changes, so you got a lot of contraction and expansion. There's wildlife to consider. And then one additional major hazard up there, earthquakes, right? This is near the Ring of Fire. So a team of engineers got together, and their slogan was, "They didn't know it couldn't be done," was the slogan they ran with, because this was like one of the most complicated, complex engineering projects in the world at the time. So here's a section of what their solution was. So they built this is a 4-foot diameter pipeline. They built it in a zigzag configuration, so there was room for it to contract and expand. And then there's this picture is showing a section near where the Denali Fault is. So there's slider beams that are 20 feet wide that pipe can move along with Teflon shoes to reduce the friction. And then it has the ability to be displaced 5 feet vertically, okay? And they installed the pipeline in really short fashion, and it was a huge, huge project. The amount of volume capacity for that line is 2 million barrels a day. So I just said earlier, OPEC is planning to cut production by 2 million barrels a day. This line alone produces 2 million barrels a day. So that's why it's such an important project back in the 70s. So they built the line. It's been in operation for a long time. In 2002, Mother Nature tested this line. So there's a 7.9 magnitude earthquake along the fault where the orange line is in that picture. The displacement along the fault was 18 feet horizontally and 2.5 feet vertically. And that was within the parameters that engineering team designed them for. And guess what? The line held. So there's a little bit of repairs on some of the supports, but the integrity of the line held, even with that enormous earthquake. So I'm just fascinated. This is an amazing example of what engineers can do. So if this sounds interesting to you, a lot of facilities engineering involved, whether you want to work on stuff that's out in the ocean, on land, lots and lots of engineering opportunities. So drilling engineering, we have to drill a well before we can produce anything from it. I have a little kind of diagram to demonstrate how drilling is conducted. We have a drill bit on the end of a hollow pipe, and there's a very specialized fluid that's pumped down that hollow pipe. It shoots out nozzles at the bottom, so as that drill bit is turned, that whole pipe is rotated, it chips at the rock, that specialized fluid cools the bit, lubricates it, and also has the viscosity that they've designed for it to pick up those rock cuttings and carry it up the annulus back up to the surface. So if you imagine, we now routinely drill 3-mile horizontal wells. So we have 1.5 miles to 2 miles down and then 3 miles out. That last bit of cutting that drill bit is going to do, those little bits of rock that is chipped away have to be carried by this specialized fluid 3 miles horizontally and then 1.5 to 2 miles vertically to the surface, where it's put in a larger container that has a lower velocity for that water so that those rock bits drop out and they reuse that fluid. So a ton of engineering involved. And there's a picture of a land rig. This is on the tourism website for North Dakota, if you believe that. And then, or offshore, this is a picture of a drill ship that's heading to Guyana. That's a country that's adjacent to Venezuela, and there's a lot of new jelly donut-like deposits that have been discovered. Big, big hot area right now. And that's a very large ship. And if I was in your shoes sitting there, I'd think, oh, there's no way I could ever work on designing something that large or being involved in an operation that big. You absolutely can. You have the right skills when you're done here. If any of this is interesting, you can totally do this. All right, the next one is production engineering. After a well's drilled, then everything after that belongs in production engineering. So we have the fracking operations, which it alluded to in the video. So this is what it looks like temporarily on a well site during fracking. You need water, sand, and pumps are the ingredients. So we're pumping water down the well into the horizontal section of kind of that straw in the video. They perforate little holes in that horizontal section of the straw and then inject water, which makes the jelly layer kind of crack, and then they fill it in with sand behind it so that those cracks stay open, because there's a lot of pressure from above to close it. That's what fracking is. So it's a temporary operation. All that equipment is moved off to the next one when they're finished. And if it's a natural gas well, it looks like a bunch of pipe out of the ground. Or if it's an oil well, it has a pump installed. Some of you probably from parts of the US where you've seen rod pumps before. A production engineer is in charge of sizing and maintenance and changing the size over time as rates decline. And then at the end, 30 plus years down the road, the well is sealed off and the land is restored back to the original conditions. So this is a picture of a pad after the wells have been sealed and then the soil restored. All right, so that concludes my part on the energy industry, and now I'm going to share some personal stories that to help illustrate some of the decisions I think that I've made that have helped me be successful, and I hope they help you. So again, I love the word bold, and to boldly go places. The first story I'm going to share is about the career fair, which I think you guys held just a couple weeks ago, and I think you'll learn something from this. So I took this picture from BYU's career fair website. I'm entering my junior year, so I'm thinking I want an internship for this fall that hopefully I get a full-time offer in so that I already have a job when I'm finishing my last year of school, is my plan. So I'm going to take this very seriously. I have my resumes all printed out. I'm ready to go. I'm going to meet somebody today that's going to change my life, is the plan. And so I walk up to the career fair, which looked sort of like the picture, and it's like, this is terrifying. And I'm really nervous, and I'm thinking, okay, how about I go talk to some people I know don't want me to start with? Then I can get the jitters out, I can have, an awkward conversation, and get some rejection out of the way before I've even gotten very far. That's a good plan, right? So I look around, where am I going to start? I see a ExxonMobil booth, and I think, well, there's no way they take double E's, so that fits that criteria. And my dad works for them and has said that the people he works with are always very friendly. So they'll probably reject me in a friendly manner. So I'll start with them. So I have it planned. I rehearsed in my head. I'm going to say, hi, my name is Michelle. Do you take double E's? And the recruiter's going to say, oh, sorry, we don't. And I'm going to say, that's fine. Can I have some free stuff anyway? My dad works with y'all. So I go over there all geared up. Hi, my name is Michelle. Do you take double E's? And he says, why, yes, we do. And then resume? And he looks, my dad works with y'all? And then he looks through, did you come to our information session last night? I said, well, no. I didn't think you took double E's, so I didn't. He said, that's all right. We'll be in touch. So then I leave. I thought, that was really weird. Okay, maybe I'll find another one to reject me. So I continue on and I go meet with people. Ultimately, that led to getting an interview with them, and then where I learned about the things I just described, that I had no clue about how big energy was, even though my dad worked there. But I got an internship with them, and that led to the rest of it. So had I not stopped and talked to them at that career fair, I would not be a petroleum engineer today. So my message to you is, go talk to people. Even if you don't think they want you, go talk to them. You never know what you're going to encounter. Okay, next one is the capstone project, which Dean Jensen mentioned. So I get back from this internship with ExxonMobil, where I do get my full-time offer I was hoping for. So I now know, entering my senior year of double E, that I'm not actually going to have a career as a double E. And I'm thinking, okay, how do I want to finish this out? I can do a double E senior project, which at the time was 1 semester. I could do it with my friends, and it would be hard, but it would be in the realm of things I'm comfortable with, and that would be nice, and that's an okay option. Or now that I know I'm entering an industry that I'm going to be a complete novice at, with people I've never met before, perhaps it would be better preparation for me if I make a choice to be in something that's a little bit like that. Because if I join Capstone, I won't know who I'm working with. I won't have any of the skills to do most of the project. I'm not even sure if there's a real solution to what they ask us to do. And then, and it's for a sponsor. It's not even for a professor. And I thought, that actually sounds an awful lot like what I'm about to jump into. And it's safer to try it out in school, since I already have my full-time offer, GPA, at that point. So I decided to do that. I joined a Capstone team, and I wind up on a unmanned air vehicle or drone project. And I'm like, oh, that'll be kind of cool. Airplanes, flying stuff, that's sort of fun. And I'll be in charge of the motors on board. And they want me to be the pilot, which was actually terrifying because I did not grow up using remote-controlled cars. So I'm out practicing in the garage of my apartment building. I joined this project, and I realized really fast I'm in way over my head. So it's the first week we have a team building project, which you might also still have in the shop. And so I walk in there. It's the first time I've ever been in a shop. There's all these rotating machines, all this noise, and I'm thinking, do people actually make it out of here with all their fingers? I had no idea how to use anything. What have I done to myself? But I stick with it. There are other ways I can contribute to my team, and I find out pretty quickly I can help, even if I can't help with the calculations of what the airfoil is going to be. I can assist with keeping the project going and on task, kind of more the project management side and motivation, and they can teach me as we go. So by the end of the project, I was one of the main folks helping actually construct our final drone, right? So get in there, stick with it, and then keep going. And then my last story related to capstone was at the very end on how you can contribute in areas that aren't necessarily where you've trained. So you're trained here to think about problems, and you can come up with solutions even if it's not exactly in your department area. So we get to the very end of the project, we're showing it for our sponsor, and they ask us to meet at a certain location, and we drive out there, and it's flat desert, which probably is not a surprise that there's a lot of flat desert around here. But we realized pretty quickly when we get there, we have never actually practiced launching this thing on flat ground because it's hand launched, right? And we've always stood at the top of a hill and launched it from there where it had time to dip below our feet, catch enough speed, and then take off, right? So we're with our sponsors. It's the maiden voyage of this particular drone because you know how timing sort of happens on projects. And I'm thinking, oh goodness, you guys, if we launch it and sort of miff that launch and it hits the ground and breaks one of the propellers, then we're like, thanks for coming, within 15 seconds. So I throw out there just, again, I'm thinking I got nothing I can actually contribute to this. And I throw out there, too bad we can't strap someone to the top of a car. And then I have a sunroof, said one of my partners, so that we end up with our designated launcher standing through the sunroof of a CRV that drove up to 30 miles an hour. We revved up the engine on the drone, and he just gently pushed it off so that at least we could demonstrate how it flew first before we did the risky hand launching part, right? So you can contribute in ways you may be surprised by. Okay, the next area is on obtaining my professional engineering license. I knew nothing about it until my internship when I saw that my mentor had one. And this story is a little less professional, shall we say. So first of all, I thought, initials after your name? That sounds pretty cool. I want to do that someday. And when I first started working and I was in this intensive training program in this new discipline, I thought, this is a great time. I'll go ahead and study and take the FE because I'm in the middle of learning all these new things anyway. So I went and did that. And then you need 5 years of experience. So I get busy doing work and school, et cetera, and I kind of forget about it. And I end up in a new assignment at a new company, and I'm talking about my dream of, I'm gonna run an oil and gas asset someday. And the colleague makes a comment to me of well, it won't be here because you'll never be a real petroleum engineer, alluding to the fact I didn't major in it, right? My undergrad's in electrical. And I'm thinking, oh, really? Watch me. So yeah, I went out and got my license for that. And I did hang it up where they could see it on my wall. But the bold part to me on here was I had to go ask for recommendations. And I didn't work around a lot of PEs, so I had to seek back in my past and write up a bunch of information about what I'd done and to get recommendations from other people I'd worked with before. And so it was a lot of work and reaching out. Okay, so to sum up what I think it means to go boldly, have confidence that you're prepared. You come from a great university and you're learning to problem solve, you can do anything. Be humble enough to ask for help. And the number one thing I hope you take out of today is my advice to seek out a mentor. You will advance faster in your career than any other method if you can find a mentor. Google is phenomenal for locating information on how to solve things, but that mentor is going to tell you what the preferred way is at whatever workplace that you're at. Use your communication skills. Your technical skills you're doing here are really, really important, but those communication skills, those technical skills are not helpful if you can't communicate it. Some examples of how I like to build teams would be having a candy dish out on your desk. So people come by, grab a piece of candy, talk to you about what you're doing, and then you have an opportunity to ask them questions about what you're working on, or remembering birthdays. A team that's cohesive is going to be a higher performance than a team that isn't. And some of you may have a great skill set where you can be the team builder person on your team. And the last about being bold is you can pivot. It could be terrifying to enter a new area, but you can do it. Some of you may be sitting there thinking, I'm pretty good at these classes, but I don't know if I love it quite the same or have the same kind of passion as the people around me that seem to be really into that. I think you guys can imagine what it looks like in my mind, to be like a real double E as opposed to the ones that are like, eh. And so for me, looking at other options was a better fit, right? So just because maybe you don't absolutely seem as passionate as some of your peers, that doesn't mean to leave engineering. That means to stay in it, and you can find there are lots and lots of roles. In fact, there's even engineering roles who are less technical and more about building teams. There's so much opportunity out there. Okay, saying yes to opportunities. My first story is about my very first internship in computer engineering. I was a bright-eyed, bushy-tailed sophomore at the career fair with a blank resume, essentially. So I had no success. And then later in the spring, I'm applying online. I finally get a phone call for a computer engineering internship. And I'm like, oh, great, I'm going to get this. I didn't get it. So I'm like, all right, I'll just do some summer school, continue on. I'm trying to graduate in 4 years anyway. And then I get a phone call during finals week. And they say, hey, so I'm not sure what you've got planned, but our first choice has decided to do something else. So if you'd like to come out, we'd love you to come, like next week. And I'm thinking, okay. In my mind, I'm like, okay, so I'd have to cancel classes, figure out housing. And he said, just think about it a little bit and call me back. So I call up my dad, and I say, hey, the engineering guy from this firm called me back. Their position's open, but it needs to be. And he's like, well, tell them yes. Well, but what about housing? I don't have a car. Just tell them yes. Well, what about canceling all that? Just tell them yes. We'll figure the rest of it out. Everything else can be figured out. So I call him back. I said yes. And a short week later, I'm in Idaho working on computer printers in a language I'd never used before with brand new technology. And yes, that was my first model of cell phone. So that was why I got to have a cell phone. The next one is on additional education. Many of you are going to ask yourself, when is the right time to get additional education? These are the questions I think you should ask. Is it the right time for me? How do I choose which program or school? Who will pay for it? Ideally, someone else will pay for it for you, right? And then how will I find the time? So it was 3 years out from school, and I'm watching General Conference, and they talk about, intelligence and knowledge, and there's like a little bit of an itch back, and I'm like, oh, they can't be talking about me. I just got out of school. I just finished this intensive training program. No way. But it lingers. So I'm like, okay, fine, I'll get more. If I want to run an oil gas asset someday, maybe I need more petroleum engineering experience. So I look into the 2 local programs, and I discover my company doesn't do distance ones. So the A&M program that was a highly ranked school was off the table, because I wasn't going to pay for it if someone else was going to pay for it. So I have University of Houston. I go ahead and take the GRE, I apply, and then I cannot get my calendar to line up with the advisor. It's not working out at all, and I have 4 weeks to do that. I'm thinking, why is this so hard? If I'm supposed to do this, why is it so hard? And again, I'm talking to my dad, and he said, well, I don't know why you bothered with that. You practically have a master's anyway from Exxon. Why don't you go get an MBA? And I thought, well, that's interesting. And I went and actually looked at my training curriculum from Exxon, and the hours added up almost identically to a master's degree in petroleum engineering. So I thought, no, well, that's good. So now I've got 2 schools to choose from that have in-person programs in Houston. And I do my research. I go to the information sessions, which I think it's important to do really thorough searching when you're trying to get answers on this. I go to Rice University. The information session's nice. I still have no interest in doing school. And then I go to the Texas one, and it's like the angels came out and sang kind of thing within the first 10 minutes, and I got up and walked out early. And I was with a friend. It's like, well, I have to go back to school. Like, I did not want to do this. But I rush, I take the GMAT I study over a weekend while I'm on the way to and from a wedding, take the GMAT, put all the information in, and I get accepted. And I have a super intensive and amazing 2-year experience. So just to think through sometimes these are not very straight from point A to B stories, right? And then now, 10 years later, I'm back at school again doing solar energy engineering out of a university in the Netherlands. Changing jobs. This is something that's going to be important also for you. My story on this is thinking long-term through what you want for your career. So I'm in Houston, I'm working on depleted jelly donut type assets, and I can see this change happening, and I'm like, I want to be part of it. So I request a transfer to Fort Worth at a subsidiary there, and not exactly on the shale teams like I wanted, but close by. And after a couple years, I realized the transfer that I'm seeking isn't going to happen in the time frame I want. And an opportunity to Denver happens. It becomes available to me. So I accept a position with a new company in Denver that I get to work on oil shale, exactly what I want. And even better, my boss there gives me the opportunity to sit in on a lot of management meetings in his place, which is the next step for me, going into management. So I'm sitting in all these meetings. This is exactly the way I want things to go. And I realize I have absolutely no interest in doing the kind of managing that they're doing. The whole climbing the corporate ladder in a big setting like that was not what I wanted at all. And I think, well, now what? I've gotten an MBA, I've done all these things. What other kind of career progression is there? Well, I learned about the consulting world, and I accept a position there. So I'm now in Dallas, and I've been there for 7 years. I'm at Netherland, Sewell Associates. So I work with geologists and engineers, and we form independent opinions of other people's oil and gas assets. So I don't get to run one, but I get to see an awful lot of other people's. And independent opinions are important for governments and board members and investors to know what those numbers actually are. So, and then a quick shout out, our recently promoted president and COO, Eric Stevens, is a BYU engineering alum. So on to the next year. So giving back, that's the last thing that I want to talk to you. You don't have to wait until you're retired to give back, okay? One of the things that you can do early, it doesn't require any money, it's just time, is mentoring others. If you once you get enough experience, you can mentor other people. You can be a mentor for other students around you. You can judge competitions like science fairs or the Student Innovator of the Year competition. Be involved in your community and the science education of where you are. From a money point of view, if you have the ability and you've got great company, especially if you have company matches, you can establish a mentorship endowment. And so there's 3 in our family. My sister gets the credit for starting this with her friend. They wanted to pay back a small scholarship, and there was a sense of urgency from my sister's friend, Wendy, to start this. And so got it all set up in civil engineering. And I thought to myself, that's really kind of cool. I wonder if I should do anything like that. Do I have a reason I need to give back? And I was like, oh wait, I had a 4-year full tuition scholarship. So I probably have a lot to give back. So I ended up setting one in the capstone program because I felt like that experience of being thrown into something where you didn't know if there was a solution, you're working with people you've never met before, was very important for preparation for what your actual career is going to be like. There are parts that are mundane, you have to write papers, it's not all just homework problems. And then the third one in the family, my dad set one up after our mom passed away. So we've got a lot of different things running on here. And then I've been able to work with those capstone students every year after it finally vested. And I'll be meeting my team tomorrow, so I'm excited for that. So in summary or conclusion, I want you to go boldly, okay? You don't have to be confident necessarily. You can be humble. There's a lot of other adjectives. You can hide all that underneath bold, okay? Which means go out there and do it. No one's gonna do anything for you. You need to be the one who goes out and does it. What opportunity are you going to say yes to next? And for some of you, that might be saying yes to engineering, right? Some of you may be kind of on the fence. I'm not sure if I belong here. I don't know if I can hack this. If you can get through the program here, you can do anything. And then lastly, of course, I think the energy industry is amazing. I love working with natural resources and in the commodity space, and it feels more fulfilling to me than my computer engineering project did. So go Cougars, you can do this. Engineering is awesome. Thank you for your time.
Our beloved Father in heaven, we thank thee so much for this beautiful day. We thank thee for this campus that we are able to gather at, and we thank thee for the opportunity we have had to hear from Michelle. Father, please help us as we go throughout the rest of our day, that we will be able to go boldly and go forth and learn more and serve others. Please bless us that we will be able to do well in classes and be able to take the things that thou would have us know. Please bless us with thy knowledge and thy help in our classes, and that we will continue to enjoy what we're doing and enjoy the education we have at this campus. We love thee dearly, and we say these things in the name of thy Son, Jesus Christ. Amen.